Let's get started. This is data modeling with DynamoDB. Just a quick overview of what we're going to talk about today. I'll start off with DynamoDB basics and just get us on the same page with terminology and some basic concepts that way. And then I want to talk about what I call from SQL to NoSQL. So I assume a lot of you have experience with relational SQL-based databases. DynamoDB is a NoSQL database. So we'll talk about what's different there. And I especially want to talk about, Dynamo can feel pretty weird if you're coming from that relational world. So why is it so weird? What is it going after? And to sort of drive some of that. Then we'll go a little deeper into primary keys. We'll talk about primary keys, the good parts, and a little bit of stuff about write operations. Again, those last couple things are a little more advanced, but hopefully they can be useful as well. So who am I? I'm Alex DeBrie. I'm the author of the DynamoDB book, which is just a comprehensive guide to data modeling with DynamoDB. So go check that out if you want. The link is down there. I'm also an AWS data hero, mostly due to my work with DynamoDB. And then, as Catherine mentioned, I'm an independent consultant. So I help people with AWS, DynamoDB, training, consulting, things like that. So with that, let's get started with some of the DynamoDB basics. And I always like to start off with some terminology, and we'll start with 4 key terms: table, item, primary key, and attributes. I'll show this by way of an example throughout here. So the guiding example kind of uses maybe like an e-commerce store, so maybe Amazon or maybe your own sort of e-commerce store. So the first bit of data we'll show is just like our customer data, right? So you can see here, I have 4 customers, myself, and 4 other just random ones. If you look at all this data together, that's going to be called a table. So similar to a table in a relational database, different in a lot of ways as well, as we'll see throughout, but a table is going to hold all your data. If you want to look at an individual record in your table, that's going to be called an item. So item, individual record, similar to a row in a relational database or a document in MongoDB. Now, when you create your table in DynamoDB, you have to specify what's called a primary key. And every item you put in your table needs to have that primary key and must be uniquely identified by that primary key. So there won't be 2 items with the same primary key. You can see here on the left, we have this primary key. It's the email address that's going to uniquely identify each item in your table. You might be used to a primary key in like a relational database type of thing, but often that's going to be like an auto-incrementing integer that doesn't really have any inherent relationship with the row itself. In Dynamo, as we'll see, primary keys are going to be very important for how you do your modeling. So it's actually going to be some meaningful data, like a username, an email address, maybe an order ID, different things like that. In addition to that primary key, you can also have these other attributes that we have here on the right. You can see I have first name, last name, profiles, similar to columns in a relational database, with the big difference being you're not going to declare these up front like you would in a relational database. So DynamoDB is schemaless. You don't declare your schema. Dynamo's not going to enforce your schema. This doesn't mean you shouldn't have a schema. You should absolutely have a data schema, but it'll be in your application. You'll enforce that, when you're writing to Dynamo, when you read items back from Dynamo, but the database won't enforce that outside of that primary key requirement. You can see within these attributes, I have just simple string attributes like the first name and last name here, but you can also have complex attributes like arrays, like sets, like maps, things like that. So you can have more complex attributes if you want. Let's talk a little bit more about the primary key because that's pretty important to how Dynamo works. So there are 2 types of primary key. The simple primary key, which has just a single element called a partition key, and then a composite primary key, which has 2 elements, a partition key and a sort key. So that example we saw earlier, with our customers in the table, that's an example of a simple primary key. Just has that single element, that email address that's uniquely identifying each item in our table. We could also, maybe we have a different table that's storing customer orders or something like that. And let's use a composite primary key for that one. So here's an example here. You can see my primary key, it now has 2 elements, right? I have this partition key on the left of customer email, and I also have this sort key on the right of order ID. So one thing to note here is I have 4 different items in this table. If you look at the top there, those are actually 2 distinct items. Those are 2 different orders that I have in my table. But they're actually sharing the same partition key. And you can see the modeling software I have here is just actually merging that value together. So both of those records have, alexdebrie1@gmail.com as their customer email. And it's merged it together. And the reason it's done that is because if you have multiple records with the same partition key in a table with a composite primary key, you can efficiently retrieve those records in DynamoDB with what's called a query operation. So if I wanted to go to this table and say, hey, fetch multiple records that have the same partition key, in this case, if I want to get all the orders for this particular customer email address, I could do a query operation, just give in that partition key, and it's going to return those items back to me. This is going to be a very efficient operation, no matter how big your table is. One piece of terminology here is that's going to be called an item collection. So if you have multiple items that have the same partition key and thus you can retrieve them with that query operation, that's called an item collection. All right, so that's basic terminology. Let's talk about from SQL to NoSQL. Again, assuming that you come from this relational database world, if you've seen anything about Dynamo and especially single table design, you might be thinking like, what's going on here? So let's talk about, why Dynamo was designed and why it acts the way it does. And I like to think about it sort of starting at a very high level and then getting down lower. So at a very high level, what were the goals that the DynamoDB team was designing toward as they made DynamoDB? There are really good relational databases out there. What was the need for adding Dynamo? What were the different capabilities they wanted? What are the goals they're aiming for there at a very high level? And then once you understand those goals, then we can say, hey, what are the choices they made in terms of features they support or features they don't support or just different things like that. And then once you know that, we can get down into the implications of those choices and how does it change your data modeling in DynamoDB. So let's start off with the goals. And I think there are three important goals that the DynamoDB team and wanted to hit here. So number one is just around consistency and particular consistency of performance. So one chart I show a lot is a chart like this, and on the x-axis here I have data size, and as you go further out on the data or on the x-axis, you can just think of putting more and more data into your database. A gig, 10 gigs, 100 gigs, a terabyte. So as your database is growing here, and on the right, on the y-axis, I have performance, right? And think of this like latency. The higher you get, the slower something is. I've got just sort of generic terms: blazing fast to sluggish to painful. If you're working with a relational database, often you're going to see a performance curve sort of like this, right? Where it starts off really good and you're happy, your users are sort of loving it. But as you add more and more data into your table, it's going to start slowing down. And maybe you need to investigate and say, hey, why is this so sluggish? Or why are our queries timing out? Or what's going on? Do I need to, increase my instance size? Do I need to add some indexes? What's going on here? And then you might finally reach some point where you actually need to re-architect because the data design you had originally isn't going to work for you anymore. If you contrast that with DynamoDB, its performance curve is going to look something like this, right? Where it's completely flat, and you'll get the same performance at 1 gigabyte or in your staging environment as you do on day one of your application being live, as you do 6 years down the road. You're going to get that same consistent performance regardless of the scale. And that's true. You can change that x-axis from data size to concurrent queries, right? And I think you see the same pattern. As you have more concurrent queries against your relational database, you're going to get slower and slower performance as it has trouble handling that. Whereas again, with DynamoDB, you're going to get that same consistent performance, regardless of your database size, regardless of the number of concurrent queries. So that's the first thing they're aiming for, is that consistency, right? I want the same response time, regardless of the database size, regardless of how much data I have in there, or regardless of the number of concurrent queries I have going against my database. Now, I show that chart a lot, and a lot of relational database folks get mad at me and say, hey, that's not true. You're not going to get that sort of performance curve if you do this, this, and this. A lot of that means make it look more like DynamoDB in how you sort of model your data. But I think it's probably true you can squeeze a lot of a relational database. But one thing I like about Dynamo is it reduces the need for expertise, right? With a relational database, you have to know sort of all these different things that you can do, but that aren't going to work very well at scale. And that requires a lot of expertise to know that. One quote I love is from a guy named Nelson Elhaj, who used to work at Stripe. And he wrote this post, and he's talking about how his biggest problem with SQL databases is that they have this huge feature set, but it's really hard to know what the operational implications of those features are, right? So some of them, if you're just retrieving items by an ID or an indexed value, that's going to work really well. But then there are these other features. Maybe that's large scale aggregations. Maybe that's multi-way joins. Maybe that's just lots of different things that work really well in tests, work really well on day one of your application, but don't work as well down the road. And it's hard to know that unless you have a lot of expertise. So that's that first goal of DynamoDB, just give you consistency without requiring a ton of expertise. Second goal of DynamoDB is just giving you predictability in your database, right? And part of that is about performance, right? Because that performance curve is flat, we have predictable performance. We can understand how that's going to work. But the second part of predictability here is around billing. And I think Dynamo has a really unique billing system here. I want to talk about that first. One thing that's interesting about DynamoDB's billing model is that you're paying for reads and writes directly rather than sort of these underlying resources, right? So if you're talking about a traditional relational database or even something like Mongo or Cassandra from different places, you're often purchasing instances, right? And which means you're choosing how much CPU, how much RAM, how much IOPS you need to handle this. And it can be really hard to translate, I have 1,000 queries per second of my users into, that means I need this much CPU, this much RAM, this much IOPS. It's hard to do that. It's hard to get a real test of a real load test to understand what you should need. So I think a lot of people end up over provisioned in that sense. But with DynamoDB, you're paying for what are called read capacity units, RCUs, and write capacity units, WCUs. And basically, a read capacity unit allows you to read 4 kilobytes of data from your table. A write capacity unit allows you to write 1 kilobyte of data to your table. So since you're paying for those directly, it's easier to sort of predict and understand what your billing is going to be. You know you have 1,000 GET requests of your user per second, and you know how big your items are, you can calculate out how much you actually need. But even knowing that up front can be pretty difficult of like, hey, how many queries per second am I going to get? Maybe you don't know. So Dynamo also has 2 different billing modes. It has a provision mode, which is where you say up front, hey, I want this many read units per second, this many write units per second, and sort of use it or lose it type basis. Or you can do an on-demand billing mode, so that's pay per use, and you just issue requests, reads requests, write requests against your database, and they'll charge you for each one of those and send you a bill at the end of the month. So if you don't have a sense of how much you're going to use that on-demand mode and get a sense of that. Once you know your traffic, then you can switch it back to provision mode and save a little money there. And the biggest thing I would say about the billing is it allows you to do the math. It allows you to get a sense of, hey, if I have this many users and they're this active, what is my database going to cost me? Where I think that's really hard to do with a relational database. Or even if you're thinking about different access patterns in DynamoDB, you can sort of pencil out and say, okay, if I do it this way, it's going to cost this much. If I do it this way, it's going to cost that much. You know, which one should I choose here? So that's that second goal of Dynamo. They want to give you predictability about performance, about billing. Last thing is they want to give you reliability, right? Because you want reliability in your database. Dynamo is a fully managed service, and it's managed in a different way than other databases, right? Like you can go to Amazon and get a managed relational database instance in RDS or get a managed MongoDB instance in DocumentDB. But each of those, you're still, you're given an instance, and that instance could still fail, maybe because you overload it and sort of bomb it, and you get that performance curve that we talked about. The nice thing about Dynamo is it's more abstracted from you, and you're not going to get sort of individual instance failures. And we'll talk about why that is, how they sort of protect you from that in a bit. And then Dynamo just has had very few outages over its time period. I think in the last, 10 years that Dynamo's been around, I could think of 1 or 2 when I was asking people, like very few outages about this. And that's usually going to be isolated to a single region. So, you can use a feature called DynamoDB Global Tables to replicate your data between regions and fail back to another region if you want to. So those are the 3 high-level goals that we're trying to get with DynamoDB, right? Consistency, predictability, reliability. Now that we know that those are the things we're going for, like what are the choices that we have to make to make these a reality, right? So let's talk about those choices next, because I think the choices drive the implications, which really make Dynamo so different than relational databases. All right, so choices. First of all, DynamoDB, the primary key is extremely important in how you actually access your data, right? So if we go back to our table, this is our orders table. We have that primary key of with a partition key of customer email and a sort key of order ID. When you're accessing your data, you're going to be querying with those primary key values. You're not going to be querying with your other attributes, right? So it's very easy to query off customer email and order ID, not as easy to query off order date, order amount, order status as it's set up here. Let's talk a little bit about why that primary key is so important, right? We can think about Dynamo, and you might think of it as like this single database instance, but the DynamoDB front end is actually fronting some partitions in the back end, right? So behind the scenes, Dynamo is going to partition your data into these different partitions. Each partition is going to hold about 10 gigs of data. So in this case, maybe we have 15, 20 gigs of data there. Now let's imagine what happens when a request comes into Dynamo. Let's say I want to insert a new order item. Someone places an order in my e-commerce store. I say put item. I give it the email address. I give it the order ID. You know, those primary key elements that are required. That DynamoDB front end, that request router there, what it's going to do is it's going to look at that partition key value, which in this case is email. It's going to hash that value and then figure out to which partition it belongs. So in this case, you know, it hashes alex31@gmail.com, figures out it belongs to partition 2, and sends it to that partition. And the great thing about this is as my data grows, I can add a third partition, or I could add 6 more partitions, or I could add 1,000 more partitions. But that very first step, you know, where I'm hashing that value and figuring out to which partition it belongs, that's a constant time operation. So no matter how many partitions I have, that's going to be very efficient to get me to the right partition. And now I'm playing around in 10 gigs of data, very efficient operation. I'm not messing around with terabytes and terabytes of data. That's why that partition key is so crucial and why they require it on almost every request that goes to Dynamo. So they're really pushing that to give you that consistency, give you that predictability and scalability. Another thing that's interesting about Dynamo is it has really clear, harsh limits, right? If you've worked with, you know, Elasticsearch, I've worked a lot with Elasticsearch, and the scary thing about Elasticsearch is you can just sort of push it until it falls over, and you don't know when it's going to fall over until it does. And that can be scary. That's true of relational databases too. But Dynamo, you know, they want to give you reliability on like an instance level, right? So what they're going to do is sort of say, your database has limits. We're going to be explicit about those limits rather than having some implicit limits and have you just run headfirst into a wall. So what are those limits they have? Number one is the 1 megabyte page size limit for a query and a scan operation. So let's go back to our orders table. I mentioned earlier how you could query multiple records using a given partition key. So let's say someone wants to fetch all the orders for a particular customer email. You know, they want to display my order history page or something like that. They give in that customer email and it returns these 2 items. And that's a pretty efficient operation. 2 items, not that hard to grab, right? But theoretically, that could be unbounded, right? I could have a ton of items. Maybe I've got, you know, I keep coming and making lots and lots of orders over many years. And now that order history page is getting slower and slower because I'm fetching all these, right? Rather than fetching all the items that match your particular query here, what DynamoDB is going to do is cut you off and say, hey, we'll return a maximum of 1 meg of data. So even if you have a gig of data that matches this particular partition key, we're not going to return that back to you. We're going to give you a megabyte of data maximum, and then you're going to have to follow up with a subsequent request and paginate through that. And that forces you to sort of, again, understand there are limits, confront those limits. They can give you consistency and predictability of response time, and you can think how to handle pagination if you need it. So that's one limit that they have in DynamoDB. Another interesting limit is the partition throughput limits, right? So let's go back to what we had before. We had all these different partitions that are handling our data, right? And in this case, we have one request going to a partition, but you can imagine just a lot of requests going to that partition, right? And just hammering that partition and hammering it so hard that it can't serve other requests and falling over at some point. And rather than letting you do that, Dynamo is going to cut you off again. So they're going to say for this particular partition, hey, you can't exceed 1,000 write capacity units or 3,000 read capacity units per second on this specific partition, right? So if you're doing that much directed traffic against your partition, what they're going to do is just reject some of those requests right back at you and throttle you and say, hey, wait a second, you got to come back because right now we don't want to get overloaded on this particular partition. So again, very explicit. Rather than letting you just sort of fall over at some unknown point in the future, they're going to be explicit about what you can and can't do. Finally, the last choice that Dynamo makes is some of the features they remove from you, right? There are no joins in DynamoDB. There are no aggregations in DynamoDB, right? And this goes back to what Nelson Elhaj said earlier, is that you know, some of these features that relational databases give you, it's hard to know their operational impacts, and especially as you accumulate more and more data, it's hard to understand how the performance is going to evolve over time. You know, let's look at this example SQL query right here. You know, where we're summing the order amounts for a particular customer. We have a sum, we have a join, we have a where clause, all kinds of things there. And you might think, hey, why is that such a big deal, right? If I go to this particular user, this user's got 2 orders, I can sum those up, it's $89 or whatever, I can return that back. But the problem here again is that this is potentially unbounded, right? What if I have years and years of orders and I'm regularly ordering and now I have all these different orders it's unbounded. Dynamo can't guarantee how big that's going to be, and if they can't guarantee how big that's going to be, they can't guarantee you some consistent, predictable performance implications, right? So they don't allow you to do joins. They don't allow you to do aggregations because of this, right? So again, they want to remove everything that doesn't give you consistent, predictable performance. So those are the choices that the Dynamo team made, right? They're saying, hey, we're gonna require that partition key. We're gonna give you clear, harsh limits on what you can and can't do, and we're gonna remove features that don't scale very well. And given that, what are the implications for you as a modeler? You know, this is what they've exposed to you as a user. What are the implications to you? A couple implications. Number one, you're gonna have more hard work up front, right? You need to do more work in designing your table than you would in a comparable relational database, right? You're gonna have to design specifically for your access patterns. Because that primary key is so important for your access patterns, you have to know your access patterns first and then design your primary key to actually handle those access patterns. You also have to maintain aggregations, right? Dynamo doesn't do aggregations natively. So if you know you have to support some aggregations in your application, you need to think about that up front and either say, hey, I'm going to do all the reads necessary to compute that, or I can pre-calculate in some way to maintain those aggregations. Second thing is you're gonna have to consider pagination and sorting, right? If I can only retrieve a megabyte of data in a single request, like how am I gonna handle that if someone has more than that? Also, you need to think about sorting in advance within a particular partition to make sure something's sorted efficiently. We'll talk about that in a sec. Finally, you might have to shard if needed, right? If you have these partition throughput limits and you know you might exceed that for a particular item collection, well, now you need to think about, hey, how am I sharding to spread that across a couple different partitions? So with Dynamo, you have to do more hard work up front, but then operationally later on, you know, you're going to get very predictable performance. You're not going to have incidents as much because you've sort of thought about those different scaling patterns. You've thought about your requirements up front and planned for those. Another thing is with Dynamo, you're going to have to use what are called secondary indexes. This is a really useful feature from Dynamo. So let's go back to our table here before. We talked about how important that primary key is in access patterns and even that partition key, right? And as this table is set up, it's very easy for me to retrieve an individual order if I have the email address and the order ID, right? If someone's placing that order or if, you know, a user logs in, wants to see an order, I can fetch that very easily. Likewise, it's easy for me to fetch all the orders for a particular customer given their email address, right? I can do that query using that partition key to fetch that. But what if I need to fetch an order by the order ID, right? Say I'm in the warehouse and I'm working an order and I want to, you know, I get this order that I need to pick. I go pick it and I say it's completed. I don't have the customer email. All I have is the order ID. How do I sort of find that sort of thing, right? What Dynamo allows you to do, if you have additional access patterns on the same data, is you can set up secondary indexes, right? So I can set up a secondary index, say, hey, I want to index by this order ID value. Dynamo is going to copy your data into this secondary index, which is like a replica of your table with a new primary key. So let's flip this around. This is my secondary index now. I set up a secondary index whose primary key used order ID as the partition key, and now I can easily go and find that particular order according to that primary key. So again, secondary indexes, what you have here is data from your base table is copied into that secondary index with a new primary key, and that new primary key gives you additional access patterns. You know, you can use read-based access patterns on those secondary indexes, so you can perform additional reads on those, but you can't write to a secondary index. All your writes have to go through your main table and then get replicated out to your secondary indexes to handle those additional reads. All right, you got a question here, Andy. Assuming that you suddenly run into collisions, would it be possible to add a new primary key later? So it depends on what we're talking about there. So you can add secondary indexes later on. So if you have new access patterns on your data, you can add secondary indexes after the fact. Dynamo will do all the replication to handle that sort of thing. If you find out that two of your items would have the same primary key and you need to change the primary key structure of your table, that's harder to do because you can't really change the primary key after the fact. You'd have to create a new table. You also can't change the primary key of a particular item itself because that primary key is inherent to that item. So if you need to change the primary key for an item, you could delete that item, insert a new item with that, a different primary key structure. Good question. All right, so third implication here. is that you'll often use what are called generic primary keys. And if you've heard anything about single table design in DynamoDB, this is what we're talking about. This is where it starts to get a little wild. I think we've been pretty straightforward so far, but now we're getting into some wild stuff. So let's talk about single table design. What single table design is in DynamoDB, you might choose to put all of your items, all of your different item types into a single table. So rather than a relational database where you have one table for customers, one table for orders, one table for items or something like that, you put them all into a single table and use that for your application. So let's just see what that looks like and why we might choose to do that. So let's imagine we have an e-commerce application like we've been talking about. We have our two entities, we have customers, we have orders. I'm going to start off showing our single table with just customers, then I'll add orders in. So here's our table that has customers in it. A couple things I want to point out here. Number one, look at the primary key and specifically the names for the primary key attributes, right? So for partition key, I'm using a generic name of PK. Partition key, PK. For sort key, I'm using SK. Sort key, SK. The reason I'm doing that is because I'm going to have different types of items in this table that might not have the same attributes, right? I can't use order ID as one of the primary key values because a customer doesn't have an order ID. Also, likewise, an order might not have a last name or whatever I want to use for a customer, right? So I have to use generic names for the primary key. I'll also use kind of weird values for the primary key itself. So you can see here I have like user hash and then the email address. And we'll talk about this a little bit more later on, but really what you're doing is you're sort of structuring and creating your items so they can be retrieved in the way that you want them. All right, let's add a couple order items into our table.
Sorry, Alex, there's a question in the chat. When needing to add more than one GSI to an existing table, CloudFormation has a limit of adding only one GSI at a time and waiting for it to be ready. Do you have any tips?
No, I don't. It's such a hassle. This is like one of my biggest requests that they would fix that because I think it seems completely unreasonable. And it's really hard if you have a couple different environments and maybe you add, a few indexes in staging at different times and then you want to roll it out to prod and now you can't do it and the deploy actually fails in that case. So I don't like it. The biggest thing I would say is work around it. And if you're adding multiple GSIs, roll out that deploy where it's adding that one GSI, let that backfill and then come back and do it again. Yeah, good question. Super hassle. All right, so let's go back to our table. We have our two users in here in our single table design. I'm going to add a couple orders into this table. So if you look here, here's our table with customers and orders. We still have our two customer items. Those are outlined in red here, but we've also added these order items in there as well. A couple things to call out. Just notice that the order sort key has a different pattern than we had for our customer sort key, right? This is order hash and then this ID. So it's using a different pattern there. Also, if you just look at the different attributes between customers and orders, right? Customers have attributes that make sense to the customer. First name, last name, profiles, where orders have attributes that make sense to that order date, order amount, order status, things like that. That's where that schemaless nature of DynamoDB comes in to where you don't have to have the same attributes. You don't have to have them declared up front for you on that particular thing. Last thing I want to note here, we talked about item collections before, where that refers to a group of items that have the same partition key. One thing to note about this particular item collection is we have different types of items, right? So we have a customer item in there, but we also have some order items in there in that same item collection, right? So that is an item collection, but we've grouped those together. And you might want to do that for certain patterns where you're grouping these together to satisfy your access patterns. I mentioned before that DynamoDB doesn't have joins, but this sort of emulates a join for you, right? If you want to go get the order history for a customer, you want to get all their orders, but you need some meta information about the customer itself to sort of decorate those orders and duplicate them down. Rather than making two separate requests, you can do that in a single efficient query request to Dynamo. It's going to be very consistent in how that performance works. So if you want to, you can create these heterogeneous collections of items to return those to the user. Cool. Last point I would say in terms of implication is just to get comfortable with denormalization, which I think is a hard point for people as well. I think normalization in relational data modeling is a good thing in a lot of places, and it makes sense. You should use it in almost all cases. But you should also think, hey, when can I relax some of the constraints of normalization? I'm not getting the benefits of normalization, and I could get some benefits if I denormalized a little bit. So one example might be to use some complex attributes in certain situations in DynamoDB. So if we go back to our customers, imagine a customer can have multiple mailing addresses on that customer, right? And because they're not going to have a ton of mailing addresses and they're always going to be retrieved in the context of that customer, you might just choose to duplicate that onto the customer itself. And you can see I have this addresses attribute that has a map of home address, business address, a few different named addresses, rather than splitting those out as separate items. And now I can retrieve that customer, get all the addresses back with it as well. So using complex attributes might be a time when you want to denormalize. You can also duplicate some data, maybe from a parent object down to some of its children. Also, you can maybe maintain a counter on a parent, or just sometimes you want to duplicate some information in Dynamo. That would be some amount of denormalization. Cool. So that's, I think, sort of like the intro parts, right? We've talked about the terminology stuff with Dynamo. We also talked about, hey, why is it so different than relational databases, and what are the implications for data modeling? Go a little bit deeper here. This, again, if you're brand new to Dynamo or something like that, this your head could be swimming a little bit, but feel free to ask questions or watch something like this later to catch up as well if you want to. So I want to talk a little bit more about primary keys, the good parts, and say what I think about those. So primary keys, right? One thing to note with primary keys is I like to split my items into what I call application attributes and indexing attributes. I find that makes it easier for me to maintain as a data modeler. So let's go back to my table, my single table design that we have here. We have our primary key, we have our attributes. You can see on that right-hand side with the attributes, that's where we have things like first name, last name profiles, order date, order amount, order status. These are all things that are meaningful in our application, right? These are meaningful to our end users, or if we need to do some business logic in our application. So I call those application attributes. Those are things that you really care about and are using that way. But you also have other attributes on your items, like primary key, sort key. I call those indexing attributes because the only reason they're on your item is because is for efficient indexing in DynamoDB. And if it wasn't for Dynamo, these attributes wouldn't exist. But you're just saying, hey, how can I, index my items for efficient use for my access patterns in DynamoDB? And that's why I have things like PK, SK, those generic values there. Likewise, if I'm doing a secondary index, I'll also add values like, I'll use generic values there, GSI1 PK, GSI1 SK. So I'm using that PK, SK pattern there. Again, those are indexing attributes, just like my PK and SK in my main table, whose sole purpose is for indexing, and the rest of the stuff is just application attributes. The second thing about primary key, we talked about a composite primary key. It has two elements, that partition key and the sort key. I always say partition key for grouping, sort key for ordering, right? So if we go back and look at our table, you can see we're grouping items according to that customer email. We're grouping, even in this case, different kinds of items together, that customer item plus a few order items there. What's that? I just have a mic issue there. Okay. If you have items grouped according to our partition key, within that item collection, they're going to be sorted according to those sort key values. And so you want to think about that sort key, be strategic about that, so that things are sorted according to how you want them. So let's talk a little bit about the DynamoDB sort key. Again, within an item collection, items are going to be sorted lexicographically by sort key. What lexicographically means, basically like alphabetical, numerical, and order. The only sort of weird things in there are capital letter. All capital letters come before all lowercase letters. Also need to think about symbols and stuff like that and where they fit. But you can look up like UTF-8 code bytes to see how that's sorted. So when you're grouping these items by that partition key, think about how you want to order those results. And especially if you're going to have a potentially paginated item collection, think how you want to order those in the same way that you'll send them back to the client, right? So some patterns that you might see here, alphabetical, maybe you want to group users alphabetically according to their username or something like that. Also, a very common one would be to use timestamps, and you can use ISO 8601 timestamps since they're big endian, they're year, then month, then day, then hour, minute, second, right? So they'll sort very nicely according to that. One very common pattern you see is you want a sortable unique identifier, right? So you want like a unique identifier, like an ID, maybe a UUID that doesn't require coordination, but you also want some sortability on that based on creation timestamp or something like that. So a few implementations you might use would be ULID or KSUID. There are a few other patterns out there, but these are really beneficial in a NoSQL world like DynamoDB. We actually use these in the order items here. So if you look at the orders, the sort key is order hash and then an order ID. That's a ULID, and what that's giving me, those first 10 characters or so is basically an embedded timestamp of when that item was created. So you can see that these items are ordered according to that order date and will sort very nicely for me without me having to embed it gives me an ID, it gives me a unique ID, but also gives me that sortability. Last thing I would say, I think this trips people up, is only group items together if you're going to fetch them together in a single request. So let's go back to our example here. I have that item collection that has heterogeneous items in here, right? I have that customer, I have those order items, and this might work for me because maybe I want to fetch their order history, but I need to decorate them with some attributes of the customer as well. And I can fetch them in a query, I can pre-join them in a way that's very efficient. But if you don't have that access pattern, if you don't need to fetch both customers and orders together, maybe you've duplicated some data, or maybe your order just doesn't need information about the customer, there's no reason to group them together, and feel free to group them into separate partitions, right? So in this case, I've got that same data, I've just given them different partition key values. So I have my customer over in one partition, I have my orders in a different partition. I can fetch those separately, and I'm not putting as much contention on a particular partition. I'm letting DynamoDB's infrastructure do the work to spread out those items better. So again, use that partition key for grouping, sort key for ordering. You also want to do something pretty high cardinality for that partition key to distribute requests, right? And we talked earlier about how there are those partition throughput limits. If you do too many requests per second on a particular partition, it's going to throttle that back at you. So what you want to do is spread your traffic across these different partitions, so you're avoiding those limits as much as possible. Again, letting that DynamoDB infrastructure do the work for you. Next thing I'd say about primary keys is you can use those to maintain uniqueness. So if you have uniqueness requirements in your application on a username, right? You don't want multiple users with the same username. You need to build those into your primary key and assert that on creation to do that. So you're often going to want to use meaningful values for that primary key, especially if you have something unique. That's how you're gonna want to do that, rather than something being an auto incrementing ID or even a UUID, not as meaningful a value in some cases. Last thing to say on primary keys is you can't update the primary key of an item. Again, that primary key is basically the essence of that item, right? It's identifying that item. So if you need to do that, you're gonna have to do a delete operation and then an insert to put that new item in. So that means if you have some mutable values in a primary key, put it in a secondary index, because Dynamo will handle that on that replication out to that secondary index. They'll handle sort of deleting that item and inserting it in that secondary index for you. So if you want to order something maybe by like updated at date, or if you have a leaderboard where scores are constantly changing, you have a mutable value that you want to sort by in that sort key, just put that in your secondary index and Dynamo will handle that for you. All right, last section, and then we'll take some questions. So let's talk about write operations a little bit, because I think people put this off to the end or forget about it a little bit. But with DynamoDB, you're always designing for your access patterns. And I always say start with your write operations first when you're modeling. Don't start with your read operations, even though people are tempted to start with their reads. A few reasons you might want to think about your write operations first. Number one, you have to provide your entire primary key when you're doing a write operation, because you need to identify the specific item that you're changing. So you need that entire primary key. You need to make sure that entire context is available for you. Also, you have to write to the main table and not to a secondary index. So you can't do updates to a secondary index. You can only update to a main table and then have it replicate to your secondary index. And the two of those combine together in sort of an interesting way, right? So imagine, again, you have your table with that primary key of customer email, the sort key of order ID. It's easy for you to create an order that has the customer email and order ID because you have that context at the particular time. But later, if you want to update an item according to an order ID, you can't do that, right? Because you need also the customer email, so you need to fetch that in some way. Excuse me. Whereas, if you did a primary key structure that had just the order ID in it, you'd be able to make that update directly without having to do a read first. Got one quick question from Eb. From your point of view, does it make sense to use the database for reporting data? Yeah, good question. Like, hey, if I have analytics type needs, if I want to do internal and say, hey, what are the most popular items we sold, or what regions are selling a lot in the last week or month over month type stuff, should I use Dynamo for that? And the answer is just no. Dynamo is really bad at that. So Dynamo is like a much more specialized database than a relational database. A relational database can do sort of your that reporting type stuff, but it can also do your OLTP like applications where you're just doing lots and lots of individual operations, right? Creating an order, creating a user, sending a transaction, things like that. Dynamo is not great at that stuff. So often with Dynamo, you'll want to offload that to some other system, Redshift or S3 plus Athena or some other type of system to handle those internal analytics queries. Again, Dynamo is really good at known access patterns, right? So you want to design for your known access patterns and handle your OLTP like operations. So yeah, great question. And Dynamo is really awesome at that. Like if you have a ton of users pounding your service and doing lots of tiny little individual operations, scheduling a car from Uber, ordering something from Grubhub, whatever, it can handle those really well, but then it's not so good at the reporting. So that's why I use that other system. Cool, going back to write operations, right? Another thing about why you want to start with your write operations, you want to consider your constraints because you're probably gonna have to include your primary key as you're modeling that sort of thing. So how do I maintain constraints in DynamoDB, right? So the main way to do that is to use what's called condition expressions. So let's say I have a uniqueness constraint where I don't want to have two customers with the same email address, right? So if I'm inserting a customer into my table like I am here, I'd be inserting that and say, hey, also assert that there's not an existing item that has that particular primary key, because if so, then I'd have a conflict. I already have someone with that email address. I want you to reject and throw that back to me so I can tell the person signing up that they already have an account. Same with like, hey, if I'm updating an order, right, I want to change it from the place status to the delivered status or something like that. When I'm doing this update, I want to assert that it's in the particular status that I thought it was in to make sure someone didn't already handle it for me, or maybe it's been canceled in and around or something like that. So I can assert these conditions on that sort of thing. So condition expressions really good for that sort of thing, This is good if your conditions are on a single item, right? When I'm creating a customer, I'm asserting that a customer doesn't exist with that same name. Or if I'm updating an order, I'm asserting that order is in a particular state. It's working on a single item there. But if you're working across multiple items, then you need to use DynamoDB transactions, right? So let's go back to our table. Imagine, again, I'm at Amazon, whatever. I have this e-commerce store. You can see I have this profiles attributes where I have myself, I have my wife, and there's also a kid's profile. Maybe they're watching movies on Amazon Prime or something like that. But additionally, I have like an admin profiles attribute, and certain users are admins without, and other ones are not. And maybe only admins are allowed to create orders or to purchase movies or something like that. So what I'm doing is, if I'm inserting an order item into my table, I want to insert that order item conditional on the status of another item. So I need to make conditions across items. I can do this in a transactional request. So I say, hey, insert this order item if the person making this order is in that admin profiles set. Otherwise, if it's not, I want to reject that order, right? And so DynamoDB transactions allows you to do that, allows you to work on multiple items in an atomic way. It either all succeeds or it all fails. But the big thing here is you want to make sure you have low contention on that. So transaction is going to sort of tie up an item for a little bit of time, and you can't do other operations on that item while it's in a transaction. So you don't want to be using something with high contention in those transactions. In that case, you need to go to patterns like a Saga or DynamoDB stream, something asynchronous or something, client-side transactions where you have multiple items with high contention can maybe handle something like that there. All right, so summary, and I can handle any more questions. Again, we just talked about DynamoDB basics, got us on the same page with terminology, key concepts, stuff like that. And then we looked at that from SQL to NoSQL, right? We went very conceptual and said, hey, if we made this NoSQL database in DynamoDB, what were the goals we were going after for this sort of thing? What are the choices we had to make as a product team in implementing that, and what are the implications for you as a DynamoDB user? And then covered some advanced stuff about primary keys and write operations. So thank you for having me. Really appreciate it. Thanks all.